factorial times x plus f double prime 0 over 2 factorial times x squared plus f triple prime 0 over 3 factorial times x squared. So now, I plug in f and all its derivatives, okay, into the original formula. So I have 0 plus f prime, which is 1 over 1 factorial times x, plus 0 over 2 factorial times x squared, plus f triple prime is negative 3 over 3 factorial times x to the third. And now I simplify, and I get 1 over 1 factorial is just 1, so I have x minus 3 and the 3 cancel, and I just have over 2, so negative x to the third over 2. And this is an approximation for the function we were given, which was x cosine x. Questions so far? Okay, so part B, now we want to use Taylor's inequality, okay, to see if we plug in any value between negative pi over 2 and pi over 2, okay, and I plugged it into here, how much away from would it be if I plugged it into here? Okay, so say I have pi over 5, okay, if I wanted to find x cosine x at x equals pi over 5, I can plug it into here, and I want to see how good that approximation is. Okay, so step 1, find the n plus 1 derivative. So again, so what is the degree here? What's n equal to? Right, because we have a third degree polynomial, so n equals 3. Okay, so find fourth derivative. And so by part A, we know that f triple prime, okay, was negative 3 cosine x plus x sine x. So the fourth derivative is, now I just take the derivative of this, which is 3 sine x plus sine x plus x cosine x. And so that gives me 4 sine x plus x cosine x. Questions? So now I have to find m. So in order to find m, I want to find for what x value, if I plug it in here, makes the absolute value of this the largest. So first, for what x in the interval between negative pi over 2 and pi over 2 makes the absolute value of this 4 sine x plus x cosine x largest. Thoughts? What do you mean 1? What is 1? X or what? X is 1. How do you know what sine and cosine of 1 are? I think you're mixing it up with the range. Why pi over 2?
Because sine of pi over 2 is 1, and then you have 4 times 1, which is going to be.
Okay, good. So were you mixing this up with this must be 1?
Yeah.
Yeah. Okay, so 4 is affecting this the most. Okay, that will have the greatest effect here. So we want sine to be largest, and sine is largest when it's 1 because we know the range of sine is between -1 and 1. So the largest value that sine can take on is 1. We want to find sine of what equals 1, and that's pi over 2 or negative pi over 2. Okay, but now we will just say pi over 2. We don't care if it's negative pi over 2 or pi over 2 because when we plug in, it's going to give us the same value. We don't care what that x value is. We just care what this value is. Okay. So just write a note here. Multiplying by 4 has the largest effect. So find largest value of sine to multiply 4 by. Okay, i.e. sine x must equal 1, and so x equals pi over 2. Questions? Okay, so then we plug in to find m. So m equals, okay, now we just plug pi over 2n. So the absolute value of 4 times sine of pi over 2 plus pi over 2 times cosine of pi over 2. It gives us the absolute value of 4 plus 0, because cosine of pi over 2 is 0. It gives us 4. Questions so far? So now we use Taylor's inequality, okay? So the absolute value of r sub n of x is less than or equal to m times the absolute value of x minus a to the n plus 1 over n plus 1 factorial. So what is A? Why?
Just the center.
Very good. So A is just a center, and from part A, okay, we were given that A equals 0, centered around 0. And what is N? Sorry? 3, right? N is just a degree of the polynomial that we found in part A, which is 3. So now we plug in, so I have the absolute value of r sub 3 of x is less than or equal to m, which in part 2 we found was 4, times the absolute value of x minus 0, okay, raised to the 3 plus 1 over 3 plus 1 factorial. And we simplify that, it's 4 times the absolute value of x over 4 factorial.
Should we say